Perfect. Well, hi, everyone. Thank you so much for being here today. I'm Stephanie Cernera, and I'm a member of the BCI Society's Postdoc and Student Committee. And today is our first career advice panel, and it is titled Leaving Academia and Coming Back, How to Successfully Transition Between Two Worlds. And this is a really unique panel because all of our panelists are actually in different sectors of the BCI field, spanning academia, government, and industry. And they all have, at some point in their career, transitioned between these sectors. So the goal of this workshop is to offer practical advice to trainees and to also inform trainees on different career paths and also how to successfully transition between these career paths. And I think personally this is really important, since especially when you're in academia or graduate school, at least in my case, I was really only exposed to academic routes or options. So I really encourage trainees who are here today that aren't sure which career to pursue or what opportunities are available to them in the BCI Society or BCI field to please ask as many questions throughout the panel using the Zoom Q&A function. And I will try my best to get to every single one before the session is over. So without further ado, our panelists here today are Dr. Peng Sung from the University of California, San Francisco, Dr. David Mcmullen from the National Institute of Mental Health within the NIH, and Dr. Mavi Ruiz Blondet from Neurable. So thank you all for taking the time out of your schedule to be here today. We're so excited to have you. So I'm going to start with the easiest question, and it is, and if you need me to repeat questions or make them a bit smaller because they are quite long, just please let me know. But it is, if you could tell us a bit about your background, education, and career path until now. When and where did you join the BCI field, and what is your current role in the BCI field? So I'm not sure who wants to start us off, but please feel free.
I'm on mute, so I can go.
Perfect.
Hey, hello everybody. So I wanted to be part of the BCI field since I was in high school for some strange reason. And then I followed a certain path, which I thought would take me there. I thought I needed biomedical engineering. There was no biomedical engineering in Peru. I took electrical engineering. That helped a lot. Then I went to a master's in biomedical engineering in the US. Then I realized biomedical engineering is a very new field. And it was, in my university, was transforming as I was joining from a interdisciplinary space to a more of a wet lab tissue growing space. And so I got the guidance of an advisor from cognitive science, which is a place I never thought about looking at, psychology, electrophysiology, cognitive science. And I joined her for my PhD. And that's where I was working with brain signals every day. That was like the holy grail for me. And at that time, around 2014, I was thinking, if I want to work on brain-computer interfaces, my only option is to be a professor. No industry is going to do this. You cannot make any money out of this. I have to be a professor if I want to keep doing this for the rest of my life. Well, anyhow, by the time I graduated, Google was doing it, Facebook was doing it, Neurable was doing it. So I got into one of these BCI companies, and now I keep like working on my dream, which is running experiments, collecting brain data, in our case, EEG data, analyzing it, finding cool results, trying to find correlates between EEG and behavior. So that's my path. My current role at Neurable is a research engineer. I do a lot of the data collection, data analysis, set up a lab, run with a team of interns who are wonderful, and provide excellent EEG data to the entire team.
Thank you so much.
Yeah, I'll go to the next and leave the last one to the most important person. So my name is Peng Sung. So I start my so at the training I was an ASIC designer. So EE, I got my PhD from Case Western. So after that I joined Medtronic. So basically before end of last year, my all career is in industry. So I called a brain machine interface. Actually, at that time, that was back 2008. At that time, I still pretty early, but we kind of more focused on like how to adding a sensing capability into the commercial deep brain stimulation device. So basically traditional, DBS device is open loop, right? For Parkinson's disease, for epilepsy, for tremor. But at that time, we are thinking of, how we could sense the brain so that we can potentially build a closed loop, therapy that'd be super beneficial. I would consider at that time it's not really BCI, but it's a kind of interface with the brain. So my career started from there. Actually, by design, the first few closed loop device called Activa PC plus S, RT plus S. Actually, recently, I think last year, Medtronic released the commercial version called Percept device. So I worked for Medtronic about 6-7 years. After release the device into the field, we call it research tool. Actually, a lot of academic group use that device for further human level research. So after that, I joined Google. And it's a very interesting transition. At that time, I say, maybe I try something new. But after at Google for about 6 years, so I kind of decided to go back to brain field. And now I'm joining UCSF as a faculty member. And so they gave me the title of professor and the director for brain interface technology. So currently I'm working on more translational research. Hopefully we can build device, can help patients in the near future. So the focus are not on fundamental, like early research, but more translational. So I'll stop here. Thank you so much. I'm really, really happy to be here today.
Great, thank you. So I'm David Mcmullen. I work at NIH, specifically at the National Institute of Mental Health, NIMH. I have a little bit of an atypical career. I come from the clinical and BCI background. So when I started down in undergrad, I got really excited by BCI. So a few years after Mavi, but it's a really exciting field, and was lucky that the lab of Miguel Nicolelis was there, and a lot of great research was going on there. And you've all heard of the work that some of the grad students were doing in the lab, and it's really exciting work. And then wanted to, I came from a psychology background, neuroscience, and thought, how can I be involved in this? I'm pre-med, like so many people are. And so I thought I wanted to be one of those functional neurosurgeons who we all know and do great work in the field. Went to med school, did some ECOG work to get some human experience, very different than the monkey BMI field. And so that was great. Did a Howard Hughes fellowship at Hopkins, continuing that work, and then started neurosurgery at Hopkins actually, and then realized kind of early on that I wanted to do a little bit more on the research side and sort of sit around and think all day. And so left that, hopped over to DARPA for a little bit, helped as a CETA there, which is sort of that first level analyst level. Happy to chat about that as well. And then met my future boss, Holly Sambi, at one of the Brain Initiative meetings. Really recommend going to a lot of meetings, and we'll talk a lot about that and networking. And she recruited me up to NIH, and I've been focused there on neuromodulation, neurostimulation, device development, invasive, non-invasive, funding that from both NIMH, Brain Initiative, and our new Blueprint MedTech program. So happy to chat about any and all of that.
Thank you all so much. So many interesting paths. So this is really exciting. So you all kind of touched on this during the last question, but just to give a more formal answer to this, what is the reasoning for switching roles throughout your careers? And then if you can summarize any advantages or disadvantages of each type of environment that you have been in, if you'd like.
We'll go reverse order this way. We'll snake back and forth. All right, so different careers, I would say from the clinical side, and for all the pre-meds and med students out there and early residents, you really have to know yourself. And I went to my to Rutgers, my state medical school, and neurosurgery is a very competitive field. So I sort of went in knowing that I need to work really hard, put my head down, but I might have put my head down a little bit too much, maybe into the sand, and didn't pick up the early signals that maybe the clinical pathway isn't for me. And thank God that people do go that way. We need our neurologists, our neurosurgeons, our psychiatrists. They treat all the patients and they really push the field forward of clinical research. So it's really important that people do continue. But yeah, you definitely sort of that undergrad, the 20, 30, 40, 50% of the undergrad class that's interested in pre-med, try to shadow some clinicians and try to think, like we often call it the meat and potatoes of this field. If you're a neurologist, you do like seeing patients with migraines, if you think of these different careers, what you'll be doing every day. So I think when I realized that it was a little bit of a mismatch, that a very long spine surgery wasn't the most interesting thing to me, I sort of left that field for more of what was available at the time, which were some of these government funder roles. DARPA was always this really exciting organization that we saw from afar, funded our lab in undergrad. They would usually hide the undergrads when the DARPA generals and funders came through, but I was always interested in that and made some connections with other CETAs and program managers at other conferences. And so was able to make that jump from Baltimore, DC, and then have continued there. So I think something that's really nice about this career is that you get to continue that sort of academic sense, especially at NIH, where you get to sit around, read papers and talk science a lot, but you're also given the freedom to develop new projects. And a lot of the work we're doing is trying to help enable translation in the field.
Yeah, so just share, my background already. So, kind of from industry for a long time now, go to academic. I think when I told people about that, people kind of laugh at me. It's, typically people go to another direction, right? From academic to industry, why you do that? So the only reason, to be honest, is I really like implantable device. I really want to work for, I would say, more novel implantable device. And based on the years experience at industry, I actually realized, if you want to make a better or maybe faster implantable, especially implantable device, the collaboration between engineer and physician is crucial. So you have to do that. When I work at Medtronic, it's so many people knows in the technology, right? They also build a lot of relationship with physicians. Their connection already there. So when I work with Google, people really innovative, right? Want to push everything fast. So you typically have the partner who knows better science, to work together. But that is still, the collaboration is not very tight. So then I'm asking myself, I think how you do that, more integrate between physician and engineer. I think one side is this opportunity come up. The second is the field, work within UCSF, like really the best medical school and some practice. I think this is maybe the way to go. So this is reason to make me to think, I really want to leave industry and join UCSF to be a faculty member here. Therefore, I can freely talk with physicians here, freely talk with a surgeon here, and even go to a surgery, right, to see how I improve, the device I'm trying to build. And also you have opportunity, really access to patient, right, to run clinical trial. For example, if you build maybe some movement disorder, you could have some animal model. But if you're talking about psychiatric disease, for example, there's no animal model. You have to try something in real patient to help them, right? So this why I think this environment is super important. I think that is the only reason make me really transition from industry to UCSF. To be honest, I only joined like end of last year, so only having a year, but I feel so helpful. I'm very excited. So I think the good thing I already said. Additional about something good within academic field is typically you have a lot of support, right? You have support from like private donation money, right? You have support from government, like Edward David helped me a lot on this. So nowadays, not only a company, but a government realize, right? I think the translational research very important. Fundamental research for sure important, but translational research also important. So we get a lot of support now. But one thing I think a bit challenge is that in company is well kind of set up, right? So you have different functions, you have legal, contracting, right? Kind of purchasing. at university, you have to do a lot by yourself. So that's sometimes I feel like a challenge. But other than that, I'm very, very happy.
Peng, can I ask a question? So how does one transition back from industry to academia? When you're a postdoc, maybe the path of applying broadly is pretty clear for the junior professor slots, but how do you go from being more established in industry to finding a position in academia?
So honestly, and this opportunity kind of find me is not I try to find, but I think one thing you have to do is you have to have the goal in your mind to keep you working on some academic related work. So for example, I have been panel, and David knows I have been panel for NIH initiative to review a lot of proposals. So I was a social editor for a few journals. So I was a technical program committee for ICCC. This is the best circuit design conference, and write papers if possible and write book chapters. So you definitely need to keep academic related work to have some credential to get back to academic. So to be honest with you, after you get a PhD, you always want to be academic. So at least my thought. So I just keep doing this over years and be prepared for that.
Wow, that's really cool path. Yeah, as you guys said, it's almost the opposite of what you usually see. Professors going into industry. That's actually what happened with my advisor. She left Binghamton to join Google X. It happened to a few faculty members at the school where I was, so it's I guess you could say it's a trend. Me personally, I've been as a professional in industry and in academia as a student, so I can only talk from that perspective. But if it's helpful at all, I can try comparing them. In academia, I didn't do much collaboration at all. It was a very star system, me and my advisor met with very other PhD students. But in industry, it was much more collaborative. You do work with other people's code and such. And I do think academia is trying to go to, as Professor Pencon was saying, it's trying to go to more interdisciplinary research. Another thing, I see a clear difference between professors and engineers, for example, from what I can observe, is that professors who are at research universities, they are really pretty much like CEOs, from my perspective. They are out there fundraising with the government, writing grants. Like, that's really hard. Just like watching the CEO at Miraval going out there with investors, raising funds. Either way, regardless if you're doing with private or with governmental money, it's really hard to convince people to give you money. So I think the skills and the grind, the effort that it takes is very similar in those two roles. Whereas when you are an engineer at a company, where you trust you trust the CEO, just like when you're a PhD student, you trust that your advisor will bring the funds. So that's a critical difference I see between being a professor and running your own lab and funding your own lab, and being an engineer at a company and being part of a bigger team.
Thank you so much. Also, I keep getting warnings that my internet is unstable, so please let me know if you can no longer hear me. But I'm going to deviate from the questions I sent you all before. And just while Dr. Mcmullen, you were speaking, and Dr. Zung, you were in these other, like you said, you really need to know yourself and set goals for yourself to know what path you want to take. Do you have any suggestions for current trainees? Just how do you know, like, you're not in the right role, or what questions would you ask yourself to really understand what you want to do, if that makes sense?
I'd say you get older. It takes time, and one of these questions, like, would you have done this pathway if you could give your younger self advice? I'd say you just have to keep thinking about these questions. Again, like I said earlier, I put blinders on for a half decade or longer, in pursuit of a good goal. But maybe that wasn't the way to do it. So all of these are very long processes. We all went through lots of training and are almost continually going through training. So maybe don't ignore some of those warning signs. And there's always off ramps and different opportunities. You can get that master's. You don't have to go through the full PhD. If you get the PhD, you don't have to do a postdoc. And not that that pathway is bad, but there are many different off roads out there and lots of different opportunities. And I think one of the nice things about the BCI space being having a commercial aspect and not being just academic is that there's plenty of different careers out there. So for me, early on, I thought there was only one career. I was a med student, I'll become a neurosurgery resident, I'll do my fellowship, I'll become attending neurosurgeon, and I will have my lab in Myers 7th floor, and that would be my life. But once you take those blinders off, there's really hundreds, thousands of opportunities out there. So I think really just keeping an eye out and trying to learn about everything that's out there is helpful.
Yeah, so I can, kind of follow up a little bit on that. I think especially when you get your PhD, you're still young. Nowadays, as David said, not at that moment define your whole career, right? You still have a lot of opportunity to try. So especially, for BCI or implantable device, I would say this industry is more like a system engineering. It's not only one discipline, right? And also I mentioned before, I'm really value the collaboration between academic, from the clinician and engineer. So actually, although it's totally different, but I would encourage people, if you are in kind of a medical school, learn some engineering. You don't have to be the expert, but at least you understand the concept. You can speak the language, the same language as other engineer. So if an engineer learns some kind of anatomy, right? At least understand the body parts, so that when you talk with doctor, you have the same language. So I would say, don't kind of give yourself too much. I just, try to learn. Nowadays, before maybe people after high school can find a good job, but now, PhD maybe just start. Just to keep learning and don't only learn, but also apply, to find something to working on, and you will find out whether you like it or not. And another kind of thing I feel BCI is really good area. It's growing, right? It's kind of going fast. If you're in an industry very settled, I would say you could have a comfortable life, but may not have a good opportunity. But this field is growing. Once you're in the growing field, you always find opportunity. Just to be prepared, right? You don't know, maybe another day you get a phone call, right? You get something, some kind of offer to you.
Okay, so we do have a question from the audience, and it is, what do you think about the development of hybrid academic positions where professors are partly relieved from grant writing, but they co-lead an R&D team in a company too?
So maybe I can take this question first. So in general, it's a conflict of interest. So depending on cost, for example, I work for UCSF. Everything I develop belongs to UCSF. So if another people work for Medtronic, everything you develop belongs to Medtronic. So there have to be some conflict of interest to work out between university and that company. I could say it's reasonable, it's possible, especially a lot of professors have their own maybe startup company, right? They typically can do both, but you have to really manage that and work through between university and that company to make sure both sides agree the plan.
Yeah. I don't know if you have any experience with PIs with academics and how tightly they work with you, but the general divide is the clinical team needs to be independent of the company. But yeah, I've seen over the years different PIs, investigators attempt to do this, and it's possible. It's just a lot of additional work. It's easiest when an idea goes out, becomes a startup, and that group is able to do it independently, but that it's often tough to let go of that. So some people take leave, they may transfer funding to different organizations, but you'll be very familiar with your Office of General Counsel and really understanding the specific rules that regulate all this.
Yes, I think definitely that is answer. But also, you know, some kind of scenario where maybe you know a lot, right? Maybe you focus on one field in your academic setting, another field for the more commercial or company setting. I saw sometimes that also happens, but in general, you have to work through with the university and company to make sure all the legal agreement between them.
I didn't know those positions existed. It's thank for the insight, because when I first read the question, I was like, wow, this is the best of both worlds. You can run a lab in the university and have like an influx of participants and do research for a company. Like the company gives you money and you do research, like it sounds, and you don't have to deal with grants. But yeah, the conflicts of interest, who owns the research? Universities are meant to have research that is open for everybody, and then suddenly you are publishing patents, or it's hard to publish a paper if it's owned by a company. So it's not a straightforward solution.
And then we have another question from the audience. It is, what would you say is the #1 skill, either hard skill or soft skill, that people in academia lack when transitioning to industry?
I can try going first. For me, a huge up ramp was the collaboration, GitHub, using other people's codes. That was one of the hardest things, because in academia, at least in our lab, we were very siloed. Of course, I knew exactly what everybody was working in, and we would collaborate informally, but nobody had to use my code. If anybody had to use my code, I could just walk through them and say, here you go, and I'm leaving. Like, and it was normally because I was not going to be there anymore. But in a company, we co-create a lot of code, and knowing how to collaborate in that sense really took me a while to learn.
So one thing I would say, #1 to me, I feel that's kind of hard to describe, but maybe I can use the one word, maybe respect. So when you kind of transition from academic to industry or another way around, just respect people there. Because for example, when you're in academic, you can think something really easy to do. So one example about compatibility, very easy, right? You just do that, it's simple. But industry will put like maybe 5-10 people, like years, maybe $1 million to do that. So it's different. I would say, so respect your kind of other side, just understand their own kind of challenge. So have that mindset, I would say it's pretty important.
So I have a question for Mavi. With some of the new open science and data sharing initiatives and sharing of code, do you think that would also help younger grad students learn some of those skills that might be helpful in industry?
Oh, yes, that's a great question. I do think science is benefiting a lot. Even my home university, Binghamton University, started like an ORG, which is an open repository, something. So it's just a place where you store the data and the code. And there is, of course, GitHub is the main place you could go for that. And right now, you just need to put it there. I don't think people actually check, but as more and more people, as papers become more relevant, as people go to the code, and having a clean code really pushes people to use that research of that paper more. I think that might be a way to incentivize better code writing, cleaner code writing that can be used by a larger community. Yeah, that's really a great push for science in the recent years.
And then another question is, how did your daily job change when you moved from academia to industry, especially for Dr. Ruiz Mondet and Dr. Zhang during his time at Google Medtronic?
so how does it job change when you move from? So I was a student. I was never a professor. I can only talk in behalf of observational study here, of observing my own PI, and then myself as an engineer at Newable. But I would say professors have a lot of freedom, but then again, they have to provide their own funds. They have to apply for their own grants, and that's what I observe, at least on my PIs. I think Professor Pencon can answer that much better. What changed? How those things are different at work? I guess it's a little bit more structured because I'm an engineer, part of a team, and my company is great. It gives us a lot of agency. It gives us a lot of, like, we take an agile course together and we decide what is going to be our day-to-day routine, like based on best practices and such. So we do have a say on how is our routine, but it is a routine where we do a stand-up at 10 a.m. in the morning. We do a retrospective. These days we do this, we put what we're going to work on the Jira board. So there is a clear difference. Like I do follow similar, you could call it ceremonies that many engineers follow in industry, that I see professors don't have to follow. Of course, they can follow if they think it's good for their productivity, but they can decide exactly what their day-to-day is going to be. It's totally up to them in what I have observed. If that's true.
I think that's well said. But just maybe add maybe two things. I would say one, when you transition from academic to industry, typically your role or your scope of work is relatively narrower compared to what you've done at academic. I think of course, depending on your position, but in general, you are not only work like how to say the big kind of scope. It's more focused on one subject. That's, I think, that typically is what happened in transition from academic to industry. The second, I would say, in industry is more structured. So the structure means two things. One is a team, right? You, as she said, you have a bigger team. You have to interact with the different people. The second is you under some structure, for example, some quality system. You have to follow procedures. You have to follow, some rules there. So I would say that is a major difference, transition from academic to industry.
How would you two say the work-life balance changes from sort of that grad student experience to moving to industry?
For me, yeah, I think early days. I think I feel really lucky, to work for Medtronic. But I would say at that time, transition from a student to a employee there, I think the life balance is much better. So as a student, you just work so hard, right? You just go through nights, finish Edison. I remember I kind of finish up my tape out, so do the layout for electronics. I think I spent many nights. I didn't even sleep. When I submitted that, design, I really had a back pain. I kind of out of bed for a few days. But I would say in industry, the work-life balance is much better, at least for me.
Yeah, for me at school, it was kind of similar. I didn't have to care about staying up late. It was up to me, as a student, I could decide kind of my own schedule besides classes. And if I wanted to pull an all-nighter, I would do it. But there are companies where you work 9 to 5, and then you go out of work and you forget everything, and you have your personal life. No. The one I am right now is a startup, so it's also not like that. I do come home, and I'm thinking,
I don't think you usually forget about the work after work, but you definitely don't need to go through many nights, right? You maybe you have to check email maybe 11 p.m. to get a kind of response, so far. Maybe work a couple times during the weekend, but it's not like a 24/7.
Yeah, exactly. And I do think, well, I was hoping there would be work jobs that would be like that. I guess then the startup is not an outlier. It's pretty similar to what you're describing, where maybe a couple of weekends I have to work in a couple of months. But it does kind of the pace is kind of fast, so it does kind of lingers on my mind. But I do not pull out all-nighters as I used to when I was back in grad school.
Is that something you ask about on interviews, or you sort of understand that if you go the large company route, you might have a more structured work-life balance, whereas if you go to the startup, it might be a little bit more chaotic?
I just assumed, and I did have a friend who had a job that was from 8 to 4, and she had this beautiful, like, day and night with grad school, right? Like, she was 4 p.m. Okay, she was home, and she had all the afternoon for all her own things. It was like a magical. It didn't last forever, it's just a period of time. Now she's in a startup herself, and it's not so much day at night, thank God. But I do think a lot of things are not settled in the startup, so you kind of there are thoughts that keep lingering, projects that you could keep working on, things that could keep happening, because it's not a lot of process that you need to maintain, it's a lot of process that are just getting started. I think that might be why.
And then going back to the question about skills transferred between each of these roles, do you have any suggestions for trainees on how to identify these roles or skills? And then any suggestions how trainees can diversify their skill set? Like if they want to go in industry, should they do an internship? Or with the coding and how to share code and make more accessible code, maybe a boot camp? What are your suggestions?
I could think of a couple of things. I would suggest joining communities of interest, for example, for BCI especially. Well, there is the BCI Society, of course. It's a community you could join. The Neurotech X, I don't know if you've heard of it. It's another community where people connect and are trying to work on projects together. So I think these are good places where you can learn what they put out, and also once you have some skill of your own, try to contribute to the community by writing a tutorial or supporting a project, it can be anything from data analysis to an experiment setup. And yeah, I think that would be my advice. And to be able to really contribute to those, you might need to good programming skills that always comes pretty handy in the current world that we live in. Programming is now like reading and writing. So if you can get a good basis on programming, on data analysis, on machine learning, there are websites like Kaggle that has courses for that for free, open databases, and you can try how well you can classify an open database. So there is a lot of hands-on projects out there, and I think that's the best way to develop a skill.
Yeah, I couldn't agree more. I think you for sure you have. I think how to say, especially for BCI, I think the one skill, I think no matter what your background, you should learn is some data analysis, and I think the key in the future for sure is data. To understand some data, get some basic coding skill. So if you are a more medical kind of background, maybe find a partner in engineering background to learn from each other. If your engineering background, maybe find some place you can learn more about surgical. And also, I think another thing is maybe useful is to think about the system. And for a BCI system, what components there, right? You need a surgical procedure to put in. You need a kind of neural interface to get the signal. You need circuits to amplify the signal. You have the data to transmit out from the brain. You have the data analysis, but think about the whole picture, and maybe identify which one you're interested most and you like the most, and start to learn more. I think nowadays there's a lot of publication there you can read, and there's some coding there you can read, you can learn. So basically, as I mentioned before, I really consider this a system engineer. It's not only one principle. you have to learn multiple, and that may make you success or not success. But for sure you have to have your own kind of skill, right? You go really deep, but this other skill you do broad and you understand. So this is my 2 cents.
Thank you so much. And we have a specific question for Dr. Mcmullen. What is your day-to-day like in your current position, and what experience do you need to become a program officer?
Yeah, so I would say the day-to-day is that NIH is it goes through cycles of funding, and so you have applications that are coming in, and so you'll talk with investigators who have interesting new ideas and try to help guide them to the appropriate funding opportunities and sort of refine the ideas. And then those applications come in, they go to review. And so you may listen in on that and then read the summary statements, which are the summary of the review concerns, talk with the PIs, try to address those, and then discuss internally and make a list of what you can and can't fund during that round. And then you go through that. And then once it's awarded, you then help perform oversight of that. That could be annually, it could be if there's data sharing more frequently, if there's any issues, PI moves, things like that. So that's, I would say, like a typical Monday. And so if you sort of flip that calendar and then make that a day, you'll have different calendar events throughout the day that fill that up. And then the rest of your day, you're filling with trying to keep up with the science, learning about what's happening, going to conferences, back when we could do that, and talking with the community, and then coming up with different program ideas. And so if like the new Blueprint MedTech program we were talking, I mentioned earlier, that can take years to develop. And so you have meetings throughout the day. So it's a lot of meetings. It was a lot of Zoom even before Zoom became a big thing, but it's a lot of talking with investigators across the experience spectrum about new ideas. So that's the typical program officer day, I would say.
May I ask a follow-up question? So, Dr. Mcmullen, you're on the other side of the table from the professors applying to the grants. You are the one who grants the grants, the one who decides which programs get funded. Yeah,
so at NIH specifically, we talk about two levels of review. So first you have peer review. So Peng sat on a lot of the Brain Initiative review panels. The community comes together and provides a score and feedback. And so that's the score driving part. The program staff provides a second level of review, the programmatic review, because we're able to see across hundreds of grants, thousands of grants, the entire field. And so we try to shuffle portfolio balance, different initiatives that we're focusing in on at that time. So yeah, we're on that side making those decisions. At DARPA, it's a little bit more top down. So you have the program manager and the CETAs, and so they'll release a BAA, a new funding opportunity, people come in, apply, and then they'll bring in sort of government experts that provide that review panel, and together with the program manager sort of make a decision on what's funded. I didn't answer the second part of the original question. So how do you get experience? With any of these, it's sort of, you have to just take that step. There, I would say, two traditional ways of doing this. So you can either come in at sort of the lower level, at the analyst level. And so that's what I did at DARPA. I came in as a CETA. That's an acronym that stands for something that we all make up every time we're asked: Systems Engineering Technical Assistance, Science Engineering Technical Assistance. But it's the analyst level in support of a program manager. At NIH, they have program analyst roles. Program specialist, program analyst might be something you hear. If you're interested in that, I would say reach out to people at NIH. Our emails are all online. They post jobs. There's both government jobs, the FTE type jobs, And then there's also a lot of contractor roles. So not a full government employee, but still able to provide that assistance. So I would say, you know, in the future, once conferences open up again, go to talks, go to the government panel. It might sound boring, but if you're interested in maybe doing that in the future, you can see the people that are talking on stage, the people off stage that might be in support of those programs. Just chat with them. That's honestly how I got my start at DARPA. Well, I'm a little bit odd. So I reached out to Dr. Jeff Lang when I was an undergrad, who was the program manager, and he was very gracious and talked with a lowly undergrad at the time. But the other way was at one of these conferences, I was like, oh, how do you become a DARPA PM? And I saw that there was people working in support of the PM, and I spoke with them and they kept me in mind. And when I was looking to leave, they were looking to hire new people on. That's another weird structure where it's actually contractors that are hired. The CETAs are all contractors, they're not government employees. They were looking to bring in new people for those contracting roles, and it just worked time-wise. So I'd say just keep talking and looking online, and it's a complicated process to apply, so you need to talk to people.
Okay, can I add a couple more here? Because I kind of interface with a program manager before. So one thing I want to highlight is like people like David, he can not only kind of see so many applications, but he kind of define what's meaningful, what's not meaningful from government point of view. So through his role, he kind of help the whole community define the direction for the field. And after a few years in that position, you are the person really knows inside out from the top level to the details, what the field looks like and what's the direction. I think for some people really, even if they want to be professor in the future, I think the DARPA program manage kind of role is really a pathway towards that. This is my kind of belief.
Yeah, I would say that reminds me. So if we're talking about career transitions and sort of going back and forth, there's, we have a limited data set. Generally, I would say people that go to, let's say, NIH. I talked about coming in as an analyst. Some people also come in later in their careers once they're established as professors, and they're focused on different things. Maybe don't want to do the grant grind. And so they come in at that higher level. It's rare for people to then leave, but as Peng mentioned before, those that are able to keep their hand in sort of the academic space, there, some roles allow for some research or following up on the projects that you had previously is one way. I would say you can look at others who have done the switch. So Kip Ludwig was at NIH and INDS as a program director before returning to academia. And so finding those people and chatting with them. The DARPA program manager is a little bit different of a path. It's supposed to be a short term, sort of like 3-year stint. They want to rotate people in, keep ideas fresh. So those positions are often, people from academia who know they're only coming for a short period of time. So Doug Weber, Jack Judy, and others both went into DARPA and then came back to their institution to continue their academic careers. NSF, I believe, also does rotations through IPAs as well. So if you're a little bit further along in your career and you sort of hear about that opportunity or seek it out, those are careers that are geared a little bit more for sort of coming in for government for a little bit, then going back out. NIH, a little bit more of a home for people, but there are examples of people coming in and then rotating out as well.
If I could offer the private company parallel of this would be venture capitalists. That's also a career you could be. Correct me if I'm wrong, but I think venture capitalists have to have a similar profile where they have to have some sort of expertise on the field, so they know if they get presented with 10 people who wants to do a BCI startup, which of the 10 they're going to fund, they need some know-how to know where the funds should go. So it's an interesting parallel, but from the private market.
So I would comment on that a little bit. At least based on my understanding, I think it's a totally different path. I think for VC, they're really kind of more from business side. Although they understand a little bit of the science, but I don't think they really go deeper. They are more from business, investment. But the DAPA or NIH, program manager, they are different. They are very, very kind of humble and understand the basic science, try to help the field. I would say a little bit different.
I know this is being recorded, but that might be the first time I've heard a DARPA program manager be described as humble. But yeah, I think the VCs, and I guess none of us are, so we're all speaking for others, but there might be a diversity of backgrounds. I know a bunch of MDs who, it's a little bit different than being full professor and hopping over. But yeah, that funding side is probably very different. NIH, it's a very academic. So I didn't even get into sort of the base level requirements for a lot of the program officer, program director, DARPA PM, NSF program director roles. That is PhD and MD type of criteria. Not for every role. There are a variety of roles at all these organizations, but if that's something you're interested in, whereas I'm sure there's plenty of other opportunities on the business side, industry, startups, VCs, equity that pull in from a variety of, like you said, more business fields, but also some science.
And then if you could go back in time, would you do anything differently? And what lessons did you all learn along the way?
So I'll go first. So if I go back, to be honest, I may not do anything differently. So I just feel also, if you go back, maybe my path will be different as well. So a lot of time is opportunity. All time is I wouldn't say it's luck, but sometimes it's opportunity, it's timing. But I think, but the more important is what you really want to do, right? Of course, we discussed this before. You may not know at the early days, but I think at least you have to yourself one kind of relative kind of clear direction. So what direction you want to do? You want to do a really academic to study kind of basic science, or you want to be more industry, or maybe in academic, but do more translational research. So I think that level, you have to be relatively clear. And if you do research, teaching or industry, I think that'd be a little bit clear at the early stage. After that, I think a lot is just try your best. So when we're talking about, from academic to industry, you said the work-life balance is better, yes, but really up to you. If you want to work hard, you can do that. No one, stop you. And if you work hard, you learn more and you get more recognized. It's really simple, up to you. So, just my advice will be, have your bigger direction defined and work hard, learn as much as possible. Just, around your field, to learn as much as possible. You never know, which your knowledge will be very useful in the future.
And then where are BCI jobs in industry advertised in general? LinkedIn, ResearchGate, or conferences?
So I would say everywhere. I think LinkedIn nowadays is really popular and powerful, especially for industry-related positions.
I think NeuroTechX is reached by lots of people who are trying to hire people for BCI, so they do get a lot of job postings there.
Yeah, and again, once we can go back to conferences, I think especially on the startup side, you'll see a lot of the founders come from the community. So you just want to keep networking and I guess make it apparent if you are looking for off-ramps, but a lot of organizations are constantly looking for people. So it's about reaching out to them.
And then What do you like the most about your job in one word? Ooh.
That's a hard one because I do like a lot of things about what.
Could be many one words.
Anyone works? No, I had to do one.
The top one.
I'll throw out two. I'd say variety and mentorship.
I'll take that. Anyone else?
So I would say maybe exciting. I'm really excited by my role now.
That's a good one. Yeah, I would say something that has been new for me in this company is teamwork. Something new that hasn't come before joining a company.
Awesome. And then what's the number one advice you'd give to trainees that don't know which path to take, or even how to get, besides skill set, how to obtain really to build and manage a STEM related career in which they would want to transition roles?
So I think first, so basically, I think the easiest way, just talk with people. Find the people in the field you are not sure, but maybe you're interested, to talk with the people. I think many people, they're typical nice people. If the guy don't respond to you, that means the guy may not be nice. So don't bother talk with him or her. So just talking with the people to learn, more about that field, and maybe take opportunity like internship or other opportunity to really try to see whether you like or not.
Yeah, I would echo that. I would say I used to not be very outgoing and sociable, but through part of this process, you need to learn some of that. So you can look at people's careers from afar, try to find a CV. But I think what helped me was once I left this very narrow path, I tried to talk to as many people as possible and almost treat it like a puzzle and just say, like, what can I learn? What is this person's, motivations? What did they go through? How did they make these decisions? And try to learn as much as possible from each person. And so that sort of helps with the networking as well, because you don't usually network and go up to someone and say, hi, do you have a job I can have? But you can say, can I learn about your career and how you got to where you are? And people like talking about themselves sometimes. And, we all went through this ourselves, probably. I know I talked with many people when I was making my career transition decisions. And so we always want to give back as well.
Yeah, I think that is really the main advice. Now with LinkedIn, you can really try to browse to profiles and try to see who has your dream job. More people than you think are willing to talk and give an interview and have some questions to ask them. If somebody has your dream job, what is the skill they need to be there? What would they say is their top number one skill that is more valuable to be where they are? And try to collect a few of those skills as you go. Try to commit to developing these skills for a reasonable period of time. And if you think that's something that you would enjoy doing for a career, then definitely by all means, having those skills under your belt will bring you a long way.
I forgot about one thing. Actually try to attend as much as possible, like these webinars. And so actually one thing is just a kind of advertisement. Actually, I'm hiring postdocs in my lab. So if you have a background like more electronics, feel free to reach to me. Happy to chat more.
And with this last remaining minute, it just ended. But if you all can quickly comment, where do you think the BCI field is headed within the next 5 or 10 years?
Nirabol is really hoping that everybody will have a device like this that is going to measure your brain signals, just the same way that everybody, like 5 to 10 years ago from now, nobody had access to their heartbeat, and now everybody just does, and it's nothing. Nobody even bats an eyelash for it. Like it's normal to have access to your heartbeat. So we do hope in the next 5 to 10 years, everybody will have access to their brainwaves just like that. And it's going to bring a lot of valuable insights about your own space of mind, state of mind.
So I would say, in 5, 10 years, I hope, for some people, maybe due to disease or injury, they cannot communicate, like they kind of lock in, and they have a way to communicate with other people freely. So I hope we can see that.
And I'll take the easy way out and say it's going to be where all of you bring it. So it does rely on the community, on the academics, on industry, on startups to really push the field forward. And so we're all excited to see where the field goes.
Well, thank you all so much for being here today and for answering all of the questions we threw at you and for also raising your own questions. Thank you all so much. It's been really fun. And thank you for all the attendees.
Thank you.
Have a great
Thank you
day.
so much. Happy holidays.